Okay, so this is going to be module 4.2, which is working on adding, subtracting, actually all different arithmetic functions with rational expressions. Remember, a rational expression is just a fraction with a variable in it. Okay, so it's a fraction with a variable. If you hear noise in the background, that's the lovely Miss S and the lovely Amanda Wooning decorating my classroom right now.
Hi.
So,
Hello.
say hello, girls. There you go.
Hi.
Okay, so number one, we can use bow tie method. We're just going to do some quick refreshers on straight fractions. Just remember how. Remember bow tie math for adding and subtracting only. Bow tie for adding and subtracting only. Okay, so you're going to multiply across the bottom, then on the diagonals. So you have 3 plus 7. 7 times 3 is 21. 3 plus 7 is 10. Okay? If you know how to do it with common denominators and you would rather multiply a different way, that's fine. I find this way to be fairly easy. So on the bottom here, 5 times 4 is 20. 5 times 3 is 15. 2 times 4 is 8. We're subtracting, so we would get negative 7 over 20. Across the bottom, you have 15. 5 times 5 is 25. 6 times 3 is 18. You would have 43 over 15. For our purposes, leave them in improper fractions. It doesn't really help to move them into mixed numbers. Okay, when you're multiplying, now you're just multiplying top to top, bottom to bottom. Canceling if you can. So 1 times 1 is 1. 7 times 3 is 21. So just 1 over 21. When you're dividing by a fraction, it's the same as multiplying by the reciprocal. So 1 times 5 is 5, and 4 times 2 is 8. Can't reduce that, leave it alone. Here you can cross cancel first. So 2 goes into 2 once and into 4 twice. So you get 1 over 14. Okay. Go ahead and do number 7 and 8 on your own. You can show the steps. Just need to know what you're doing. So bow tie method is going to help actually when we're doing the rational expressions, because we kind of use the same process to add our rational expressions. So you would multiply across the bottom, so you get 10. What you're really doing here is multiplying by the opposite denominator. And that's what we're going to use with the rational expressions also. Denominator. So that would be a 5 and a 6, so you get 11 over 10. This should be a multiplication on this one. When we're multiplying them together, we're just multiplying top and bottom. So this is multiply. You would get 3 over 10. So you multiply top to top, bottom to bottom. Rational expressions are going to follow the same trend. Back here on number 7, we were adding. You're multiplying the numerator by the opposite denominator. So that's why we're multiplying on the diagonal. Okay? All right, next page. So we need to talk about how rational functions kind of behave and where they work and where they don't. So remember that if you have a fraction with a denominator of 0 is undefined. So for example, if you have 3 divided by 0, that is undefined at that point. You cannot undefine. You cannot divide by 0. That's a key thing in rational exponents. So the roots of each function and domain of each function. To find the roots, you should know this from our polynomial unit that we just did. So you set this equal to 0, equals x plus 5, x plus 2, and x minus 4. And then individually, you're setting them each equal to 0. So you would have x plus 5 equals 0, x plus 2 equals 0, and x minus 4 equals 0. which essentially to get your answer, you're taking the opposite of those. So x would equal -5, x equals -2, and x equals 4. Okay. For number 11, we just need to factor first. So you would have x plus 7 and x minus 3. Set those both equal to 0. So your solutions would be x equals -7, x equals +3. Remember, factors are the opposite of solutions. Okay. So number 12 kind of proposes an interesting situation. So I want you to think about what number would make that denominator equal 0, because we know that at 0 that function is undefined. So if you set that denominator equal to 0, whenever x equals 8, that function is going to be undefined. So the domain for 10 and 11 were both all reals. Any number we put in there will work, okay, for both of those functions. But for number 12, 8 will not work because that will give us an undefined function. So it's all reals except x equals 8. Okay. Number 13 is actually going to have two numbers that will make this undefined. So you set those each equal to 0, because if either one of those numbers are 0, then the product of that denominator is going to be 0. So you would get x equals -7 and x equals 5. So our domain is going to be all reals except x equals -7 and x equals 5. Okay. Go ahead and do number 14 and 15 on your own, and then come back and check your solution. Okay, so again, we're setting these equal to 0. And so our solutions would be at x equals 9, x equals -9, and x equals -1, and it would be all reals. For number 15, you need to factor first. You would get x plus 6 and x plus 4. Set those equal to 0. So your solutions would be x equals -6, x equals -4, and your domain would be all reals. There's no, when we say all reals, it means that there, for every value for x, that is a function that we can find a value for. Okay? All right. So now we need to get into adding and subtracting rational expressions.
I need tall people.
So for the third section, the adding and subtracting rational expressions, I'm going to do that in a video labeled Module 4.2 Part 2. So close this video up, open that one, and then we'll continue on.